my AC is not responding, and my thermometer shows no power. So this thing already replaced the battery, so it's not the battery issue. There's no power. Okay. I have another. This is a Google thermometer. Basically, it shows the same symptom. No power. And also I replaced the battery here, so it's not the thermometer. So let's go check the AC breaker outside, see what's going on. The power meter, this panel is supposed to be our AC main breaker switch. Okay, the main principal is on. 1.3 is AC. Apparently it's on. 5.7 is a dryer. It's on. The sub panel is on. But just in case, for the AC 1 and 3, I'm gonna power cycle it. So, off. A few seconds. On. So don't think the main power has any issue because the dryer is working. Alright, let's go check the upstairs furnace AC unit. Alright, so we already checked the outside electrical panel for AC. The breaker is not tripping, so we came up to the attic. This furnace control center. We can see the power is on, but the power is not on the controller. Okay, and the unit remain off. And let's check the float switch, see if there's any water dripping. Oh, looks like the pan is dry. Okay, the pan is dry and there's no water or a sign of leak. So if we do have a lot of water, see, this is a float, this one, and water, if there is enough water, the float will go up with the water level and until it stopped here, and then it will shut down the power to the unit. But looks like it's not this case, and this float stayed normal, and it's not this float issue. So the problem is inside the unit. Okay, let's open it up. Let's check for the status, but be careful. Okay, open, gentle. Oops, I broke it. Okay, put it aside. Alright, since we have power to the unit, and then we have a flashing, and then let's find out. Okay, so constant off, not the case. Continuous on, not the case. Rapid flashing, looks like it's not the rapid flashing because it means the polarity reverse. That's not possible because this unit hasn't been touched for 10 years. Nobody is reversing it. So let's read the code. Took me a while to figure out what does that mean. So okay, the starting point. Short flash, 1, 2, 3, 4 long flashes. Okay, so the first 2 rapid flash means the first number, 2 rapid flash number, and then the 4, 1, 2, 3, 4 long flashes means the second number, so it's 24. Secondary voltage fuse is open. Check for short circuit in secondary voltage, 24 volt AC wiring. Alright, so give us instruction. So we're gonna check the for the fuse. Okay, if the fuse is blown, that would be an easy fix. Okay, let's get to the work. Find out the 24 volts AC wiring. Okay, turn off, and then the flashing's gone, so that means no power. Open this up just to find the 24 volts circuit, and should be right here. I can get it off here now. Alright, with this panel off, alright, so that's this is our circuit. Let's see if we can find a fuse. Okay, so that's the 3, see that's 3? It's purple, 3. It should be the 24 volts fuse. Okay, let's pull it out and check. Alright, see if I can see inside. It looks blown. Okay, I think I can see it's blown. Let's verify. Okay, that's 0. And then let's put on the fuse, see if it's okay. It's open. Yep, it's open. Confirm. The fuse is blown. Okay, let's see one more time. Fuse. Okay. See, this is 0, and now if I push it here, it's open. Okay, so we found the culprit. It's here, 3 amp fuse. Let's go find the fuse to see if this fixes the problem. Okay. Okay, now I got the 3 amp fuse from AutoZone. How many units? Probably 6 or 5 of them. $6.72. Now let's see if $6.72 will fix our AC problem today, saving you hundreds and hundreds of dollars. Okay, let's get one of the fuse installed here in that fuse location. Okay, let's get to work. See, that's the fuse position. Fuse 3 amp. Okay, so this 3 looks like a E, you know. If you look at this way, it looks like E, but actually it is 3 amp. Okay, but somehow this one make it looks funny. Oh, maybe let's check for continuity. Okay, for conductivity. So it's 0. Okay, now we're gonna check the fuse. Oh, the fuse is conductive. All right, let's try it. Put it in. All right. Let's install the inner panel, because you see this one, once you remove the panel, it shuts off the power, so this one has to be closed. Okay. All right, let's try to turn on the power, see if it works. Voila! The power is on. Casa, 91 degrees. Oh, it's hot. Okay, constant on. I think we fixed the problem. Okay, let me install this panel. Okay, we'll be back. All right, so the panel is back on, and then the power stayed on. Okay, let's get things ready and then check the thermostat downstairs. All right, come back. All right, instantly this thing says 80 degrees. Okay, let's see if I can turn on AC mode. Second floor. How about set up to 78? Cool. Okay, 76. Okay. One moment, please. Ooh. Looks like it's working. Cool set to 86. Okay. So I think we fixed the problem. All right. Let's. I can hear the AC kicks on. All right. All right. We're blowing again. You see that no power. Blowing again. So we come up here, and then this, of course, it's 2-4 again. So the fuse is blown again, and then we got bigger problem. So we need to keep further diagnosing. Okay. All right. So coming back from break, let me turn on the light. So let's check the filter. Is the filter dirty? The air can't get through enough, and then it might be blowing the fuse stuff. Okay, let's take a look at the filter. Not too bad. It's rather clean. I just replaced it not too long ago. Let me see. Okay, filter is not too bad. All right. Okay, let's keep digging deeper into the issue. It is always found that, and also annoying that the fuse keeps popping. But yeah, this will practice our troubleshooting skills and then enhance our knowledge for this AC unit. So once we fix this problem, I think we can become pro. Okay. All right, guys. So after our study, we found out that the reason that keeps the fuse popping could be only 4 reasons. One is thermostat wires. The second one is thermostat. The third one is the indoor wires, and the fourth one is outdoor wires. Okay, so the reason I found out the unit is not working is when I try to switch the heating mode to cooling mode from winter to summer in Texas. So that's why I find out the thermostat is not working. So maybe one of the wires is popping. So we're gonna check to see if the thermostat wire is loose. Okay, so there's no power. Okay, basically we're gonna just rewire everything. See if that helps. Okay, that's good contact. The red. Oh, the red. Okay, good contact. Yellow. It's good contact. Blue. Common. Okay, good contact. What about the white? Okay, good contact. We'll do the same thing for the upstairs unit. Okay, let's go. All right, so this is the upstairs unit. We're gonna do the same thing. Yeah, still good. Still good. Okay. All right, since we found the problem when we switched from heat to cool, let's switch back to heat. Let's see if the heating circuit is good or not. All right, so let's put in another fuse again. Let's shut off the unit, shut off the power. Okay. Our newly installed fuse is blown again.
Oh my gosh.
Yeah. Looks like it's blown. Yeah, I couldn't see the contact. Yeah, it's blown. Yeah. Alright, so let's put in another one. Alright. Okay, let's check the recently blown fuse. Okay. Okay, so this is the blown fuse. Yeah, it's blown. Okay. Second victim here. So let's put in the third one. See? Okay, so it's a good fuse. So we still have 3 more, but we're not gonna just keep blowing it. Okay, let's just install it. I'll buy a resettable fuse if this one keeps blowing, but hopefully this stays on because I'm changing back to heating mode. All right, so power back's on. Let's try to turn on the heat. See if the heating will keep the system running. No cool setting.
Why is it gray?
Okay, it's setting to the heat mode. Okay, heating mode.
Boy.
So we're gonna just check.
Oh.
Okay.
Turned on.
So this one. Okay. So the furnace is working. So okay. We're setting up the living room to heating mode.
Oh boy.
Okay, so the heating mode works. That means there's nothing wrong with the heating circuit and everything runs fine. It's just a cooling mode, okay? So that means the one of the 4 reasons that is not working is the cooling unit outside is probably have somewhere shorted, okay?
Yep.
So now we're gonna turn off the heating mode.
I'm scared. There's an open flame.
Yeah, we're
Careful.
heading
Do not bring your children up in the attic.
Okay, we're heading up
I
heat.
like it.
Okay. Bye bye heat.
Bye.
Alright, this is the following morning. Let's check the condenser unit outside. But before we do that, let's shut off the AC power. 1-3. Shut it off. Alright. Let's go to the condenser unit. Alright, here's our condenser. As usual, safety. Pull out that sink. Alright. Yeah, if you saw my video last year for fixing the AC, the capacitor, you know how to take off the cover. So I'll just skip this part, open the cover directly. Okay. Alright, with this cover open, we can see that this is the capacitor that I replaced last summer. So this one's bad. It still looks pretty clean, and I checked all the wires. They seem pretty good, and there's no net of exposed wiring, and everything looks good. You know, everything, yeah. So I'm gonna check the contactor. Okay, I'm gonna measure the 24 volts contact. So I'm gonna unplug all the wires. If the contactor is good, and from here to here should measure no less than 8 ohm. If it's under 8 ohms, that means it's completely shorted. Okay, so if normally around 8 to 17 ohms. That should be good. So let me take off all the wires. Okay. Okay. So of course, take a picture of all the wiring before you disconnect them. So you may find it hard to restore to the original state. But yeah, also take a picture of this contact manufacturer and also the serial number or the model number in case you need to buy it. Okay. Let's get to work. All right, so without this wiring disconnected from the contact, let's measure the resistance, see if the contactor is short. Okay, now reading 1.2. Gonna let you see. All right, 1.2. Okay, 1.2 ohms. So that's way shorter. So I believe this contact is shortened. Okay, so just go get a contact, and then but before I make sure see if each terminal is shortened to the ground, I can do this, and one touching the unit side or the ground, and one touching here. I'm supposed to see open. Yeah, it's open. Let me show you. Okay. See, the ohm is open. The other side. The other side. And it's still open. Okay. So I believe this contactor is shortened. Let me just try to find out. It's only $10, something like that. We'll make sure we get one. Okay. All right. For the future troubleshooting for the continuous blown fuse, I got this resettable fuse set. So there's a bunch of fuses that you can reuse, you know, during troubleshooting. So you don't have to replace a blown fuse each time. So this is a 3 amp resettable. See that little you know, click? So once it's popped, you can just reset it. So let's install this one and then see if the fuse keeps blowing. Okay. All right. So this is internal, and then this is a second blown 3 amp fuse. Let's remove it. Let's install this troubleshooting one. All right, and let's close this up. All right, this 24 VC contact finally arrived. Let's take a look. All right. Okay, similar. Okay, let's measure. Okay, let's see the regular good one. Yep, 16, 19 ohms. Yep, that's normal. So it should be like 10 to 20 ohms. Yep, this one. Let's take a look at the bad one. See this bad one. Only 1.2 ohms. That's too small. So anything less than 8 ohms considered as bad or short. Okay, so let's install the good one and see how it works. All right. All right, so the new one is installed, and then every wires goes back to their original position. So okay, let's power it up to see what happens. All right, so the contact is installed. Let's put on the breaker here. See, lower blade down. Okay. All right. All right. Let's power it up. All right. All right. So everything's ready. We can fire it up, see what happens. Living room, set the mode to cooling. Second floor, set it to cool. Finally kicks on. All right, guys, consider the problem solved. Okay, now it's running. Fans blowing, kicks on. All right, good job, guys. All right, here's the failed component, the 24 volts AC contactor in the condenser unit. One must be wondering what make it fail. All right, so let's just open it up to see how it works and what's the failure mode. Okay, so it's rather simple. Just 2 screws on the back panel. Alright, so once we pull this cover off, and it's pretty simple. This is the contact that's float up in the air, and this is a coil unit. The one that we measured here, it's a coil. Okay, and then below is a spring. Okay, so with this thing here, it's up in the air unless it's pulled down, like magnetized by the coil. Okay, otherwise it stays in the air. So how it works, when the thermostat is at off mode, and when you set it to a cooling mode, or you set it from heating to cooling mode, and then the thermostat sends the 24 volts to the motherboard upstairs in the attic heater, and then the motherboard sends the 24 volts and checks the circuit, and if it's safe, it sends the 24 volts back down to the condenser unit, and then it applies 24 volts on this tool, on this tool side. So this coil is energized, and it attracts this contact down, and it compresses the spring inside, and it makes the contact here. So the 120 from here to here will go through and make the circuit. So that energized condenser and started the cooling process. And then in our case, somehow this coil is shorted inside, or aged, or whatever. The specification for this coil is 10 to 20 ohms, but in our case it's less than 8 ohms, and it's a 1.2 ohm in reality, and then considered short. So once the motherboard senses this is a short circuit, so the short circuit can create much higher current, and then it will blow the transformer and the motherboard upstairs. So to protect the transformer and the motherboard, so the system blown with 3 amps fuse instead. Okay, so that to protect. So in our case, there's 2 component failure. One is this guy, and as a collateral damage, the 3 amps fuse upstairs in the attic. Okay, so this is not a easy troubleshooting, but it's also not too complex. We can consider it's intermediate. Okay, there's really nothing we can do about this failed coil. It's just a coil. Okay, once it's down, it's down, and we'll get a new one. All right, so my advice to Since this one and the capacitor that we replaced last year are most frequently failed component, I advise you to keep a spare capacitor and a spare contactor. So just in case in the hot summer it fails, then and when you identify they're failed, then you can replace them right away. So this completes our failure analysis. All right. Hope you hope this helps. All right. If you like my videos and troubleshootings, consider like it or subscribe. You know, spread the message to your friends, and then maybe you can help them out as well. All right. So yeah, guys. See you next time. Bye.